Piezometers. Okay, what is the piezometers and what does it do in a pipeline? Imagine this is a pipe that has got a running flow inside, and we have a standing pipe that we want to just measure the potential energy of the pressurized flow or fluid here. If we just put it like the pressurized flow or like a standing pipe here to just measure the pressure, the level of the water will stand here. That represents the pressure of the fluid in here. And at the top of that, we have the water level, or we call it like a piezometric level. And this standing pipe is called piezometer. And the pipe and standing pipe show and represents the height of the H here for this specific point, for example, point P. And in here, if you have like a specific like a depth, we can say the water pressure of flow in pipe is equal to P at point P is equal to rho GH, which is rho is the density of the water. If the fluid is like here is the water, G is the gravity acceleration, and H is the depth of the columns of the water in a piezometer, or is this a standing pipe? We have another like the apparatus is called manifold. Manifold looks like, for example, two standing pipes in this figure that at the end they are connected to each other through the pressured air or pressurized air. So this air is pressurized, and because the flow is running, the pressure in one of the pipe is higher than the other one, and in this way we can just calculate the difference of the pressure in this level. For example, at point that the first one, the upstream one, if the pressure is denoted by P1 and equivalent depth or the corresponding depth of the liquid is equal to H1, at point 2 P2, the corresponding depth of the fluid or the pressure is equal to H2, we can write the pressure at point 1 or P1 rho g H1, okay, plus PA or the pressure, air pressure here, okay, and imagine the PA is the air pressure here. At point 2, we can write P2 is equal to rho GH2, which is H2 is the corresponding pressure at this point, plus PA, and PA is the pressure at the top. So this kind of like the pressurized air, there's like a valve here that we can release or remove the air. That's called bleeding as well. The bleeding looks like, for example, radiator. Once we want to just remove the air, we can call it like a bleeding. So this kind of like the valve is for adjusting the pressure at manifold here. Okay, so if we just look at the piezometer and we learn that the pressure with the depth of the H can be calculated by this formula, rho GH. So there are like a few facts that we need to just understand. First of all, if the liquid has got like a uniform density, so we have like a uniform density liquid, the pressure is calculated by using this formula. The pressure at the point caused by the weight of the liquid, for example, any points here, for example, can be calculated by using this formula. For example, if we're just going to calculate the pressure at this point, somewhere in the middle, the weight of the liquid above that point is the amount of the pressure. So imagine in the center line at point P in here, the amount of the pressure is calculated by using this formula. So at any point, the depth of the water to the top, to the water surface that we can have here, like atmospheric pressure, which is the open-ended, by the way. This is standing pipe or piezometer, is open-ended. Is calculated by using this formula, and H is the depth of water from that point to the water surface or atmospheric pressure. And if you have like the same level in a continuous liquid, for example, two pipes of the uniform density, liquid of uniform density, the pressure is constant. So this is like the fact, and we can equal, which has got like an equal level and the equal pressure principle. Just in case if you have like a stratified liquids of different density. For example, we have the water and oil above that. The total pressure is sum of the pressure caused by each liquid. For example, if this column has got two different the liquids, water and oil, for example, the total pressure or the pressure at point P is equal to the pressure of the water part and also the oil part on the top of that, with corresponding depth or H corresponding to the relevant the elements. So with this kind of the introduction, if we just look at the situations of a tank, for example, in this figure on the top left, we just normally use the pressure gauge to just measure the pressure at any points in a tank. For example, at the bottom of the tank, the pressure gauge shows the amount of the pressure that can just be used and show the the amount of the pressure of the whole the depth. On the figure on the right hand side is the representation of the pressure for water supply for any kind of a household or any kind of the users that are connected in a water system. They normally have the pressure. For example, once you open the tap, you will see there is a pressure behind. And for example, one typical the type of the providing the pressure is by using the elevated tank here. If you have an elevated tank with a specific depth, for example, if the household here to the water surface at the elevated tank, the difference is 100 feet. For example, in this case, that the depth of the elevated tank is 40 feet. In total, once you open the tap in this house, you will see the 100 feet pressure behind the tap, and it's because of the pressure head behind the pipeline. Normally for the mains water, the water that comes from the network and from the mains, usually, or the pipeline or the mains, we normally have the pressure between 30 to 70 meters. Okay, so normally for household that you have, you will have the minimum of 30 or to maximum 70 meters. It's a typical values. In some cases, you might just feel, or in your household, you feel a pressure less than this value.